So now we will be seeing the generation techniques of AM waves. Means how do we generate this standard AM wave? So we have two techniques in our course, namely Square Law Modulator and harmonic switching modulator. In this class, we will see this Square Law Modulator, how the Square Law Modulator is used, how the circuit is used to generate an AM wave. So it basically requires three features. First one is a means of summing the carrier and modulating waves. So we need to sum this message signal M of t and this carrier signal. And the second one that we require is a nonlinear element, a nonlinear device. And the third one that we require is a band pass filter for extracting the desired modulation products. So here this RLC circuit is a band pass filter which is tuned to frequency FC, which is carrier frequency. So we require these three features here, that is summing the carrier and message signal, a nonlinear device, and a band pass filter. So semiconductor diodes and transistors are the most common nonlinear devices that are used for implementing these square law modulators. So we can either use these diodes or transistors to model these nonlinear devices. And the filtering requirement is usually satisfied by using a single or double tune filter. So in general, this nonlinear device can be modeled as shown in this equation. So if V2 is the output of the nonlinear device and V1 is the input of the nonlinear device, then this output V2 can be expressed as A1 times V1t plus A2 times V1 square into t, where A1 and A2 are constants. So this is in general used to model the nonlinear device. So if we remove this part and we are considering only A1 into V1t, then it will become a linear device. But since it is a nonlinear device, we should include this second term, which is square of the input term. So here, as can be seen in the figure, this input voltage V1 is the sum of message signal and carrier signal. So V1t will be M of t plus AC cos 2 pi FCT. So now V2 can be written as A1 into this one is V1t plus A2 into V1t whole square. So V1 of t is M of t message signal plus AC cos 2 pi FCT. So I am writing it as omega CT. 2 pi FC, I am writing it as omega C. And so for nonlinear device, V2 of t becomes A1 times V1 of t plus A2 times V2 square of t. So if we substitute this V1 value over here, so this one will be A1 into M of t plus AC cos omega CT plus A2 into M of t plus AC cos omega CT whole square. So now if we expand this, so this one will be A1 times, so A1 times M of t plus A1 times AC cos omega CT. A1 into AC cos omega CT plus this term will be, as this is a square term, so the third term will be A2 times M square of t plus A2 times AC square cos square omega CT plus, so A square plus B square plus 2AB term is there. So A2 into 2 into m of t into AC cos omega c. So this will be the expansion of this equation. So now as the after nonlinear device, we are using a band pass filter which is tuned to frequency fc. So here omega c is 2 pi fc. So it will pass only the terms which are having the frequency component fc. So if you observe this first term, there is no frequency component here. So it's m of t means it will be having a frequency component of f of m. So this one will not be passed. So coming to the second term, it is having frequency component of fc. So this term will be passed through the filter. So again, m square of t will be, so its frequency component will be 2fm. So this one will be fm, and this one will be fc. And here AC square cos square omega ct. So here the frequency component will be 2fc, and here the terms are m of t into cos omega ct. So here the components will be fc plus fm and fc minus fm. So since the filter will be passing only the frequency components which are centered around fc, so only these two will be passed. So if we take these on one side, so a1 AC cos omega ct plus, so this is having the frequency component fc, and these are the components. So as it is a band pass filter, it will be passing these frequency components also, fc plus fm and fc minus fm. So these two are the terms which will be passed, and this fm and 2fc will be rejected by the band pass filter. So this will be a2 2 m of t AC cos omega ct plus, and these remaining three terms are unwanted terms. So if we take this a1 AC common and cos omega ct, so if we take this a1 AC and cos omega ct common from these terms, so we will get 1 plus, so a1 AC cos omega t, so first term will be 1, and this one will be, so AC is already there, so it will be 2a2 by a1 into m of t plus unwanted terms. So the final equation will be this one. So after passing this through a band pass filter, so these unwanted terms will be rejected, and only these terms will be passed through the filter. So if we compare this with the standard modulation AM equation, so it is of the form AC into 1 plus Ka m of t into cos omega ct. So this is AM wave, standard AM wave with Ka is equal to, so if we compare this Ka value is 2a2 by a1. So this is how we generate this standard AM wave by using square law modulator. So once these after nonlinear device, we will be getting this output, and by using a band pass filter, we will be passing only the frequency components omega c and rejecting the other unwanted terms. So this will be a standard AM wave with amplitude sensitivity 2a2 by a1.
Sir,
Yes.
last నుంచి థర్డ్ స్టెప్ ఎలా వచ్చింది చెప్పండి ఒకసారి.
Last one's third step. This one. Ida?
పై ఈక్వేషన్ నుంచి కిందది ఎలా రాస్తాం?
So what I am doing is I am separating these components which are having FC on one side. So here in the first term, the frequency component is Fn. Here the frequency component is Fc, and m square means the frequency component will be 2Fm. Cos square omega ct, it will be 2Fc. And for m of t into cos omega ct, the frequency components will be, so if we simplify it, so Fc plus Fm and Fc minus Fm will be the frequency components. So here, if we observe, these two are the only terms which are centered around carrier frequency Fc. So as we are using band pass filter, which is tuned to frequency Fc, so it will be passing. So it will be, if it is tuned to frequency Fc, so it will be passing only these components. So Fc plus some values and Fc minus some values. So this Fm will be rejected, 2Fm will be rejected, and 2Fc will be rejected. So only these two terms will be passed because these are only terms which are centered around Fc. So this is the reason why, that is the reason why I have written these two components on one side. That is A1 into AC cos omega ct plus this term A2 into 2 into m of t plus AC cos omega ct. So only ఈ రెండు టర్మ్స్ మాత్రమే Fc సెంటర్లో మీన్స్ అరౌండ్ Fc frequencies are there, and these remaining terms are not centered around Fc. So that's why I have treated them as unwanted terms. So now when we pass this device through a band pass filter which is centered around Fc, so as it is centered around Fc, it will be passed, and as it is centered Fc plus Fm and Fc minus Fm, this term will also be passed, and these will be rejected. So the same thing is shown here. So the terms which are highlighted in red, so these are the only frequencies which are centered around Fc. So, by taking these required terms on one side, so you can write it as A1 into AC into 1 plus 2A2 by A1 times m of t plus cos 2 pi Fc. So this is the standard AM wave, and the remaining terms, these are unwanted terms. So if we compare this with the standard AM wave, which is of form AC into 1 plus Ka m of t, so the first term is the desired AM wave with amplitude sensitivity or Ka value, which is equal to 2A2 by A1. And these remaining terms are unwanted, and these are removed by using the band pass filter. So as we can see here, this V2 is passed through a band pass filter which is tuned to Fc. So it will pass only these terms, and it will be rejecting these unwanted terms. So this is how we generate the standard AM wave by using this square law modulator.